Hello again. All right. So what is the average of 90 and 123? All right. So when you see what's the average, that just means add up all the numbers, divide by how many you added together. I just added two numbers together. So I will divide by 2. Okay. And so 90 plus 123, I add together, divided by 2, I get 106 and a half. So what does that mean though? It means, well, if you've got like, one friend has 90 M&Ms and the other friend has 123 M&Ms, on, on average, what do they have? Well, 106 and a half. Or I guess another way to do it would be to say, if we put all of them together and then divide them up evenly, each kid would get 106 and a half. So I imagine you already knew that, but if you didn't, no big deal. Here's how to do it. Okay, now let's make sure we can understand how to read a tally table. I don't know about you, but for me, this was a very natural way of recording information when I was a kid. We'd play a game outside and just draw a tally table with chalk on the sidewalk. But all right, so Linda asked her classmates to choose their favorite color or flavor. She ended up with the tally table below. How many students chose chocolate? This table is wrong because chocolate is not the top flavor, or Linda just has a lot of weird friends. So that would be, yeah, there's 1, 2, 3, 4 tick marks for chocolate, and that's it. If I try another one, how many students chose grape? 4 again. Okay. And then if they asked for cherry, it would have been 9 and so on. Okay, so now, group of 7 students was asked, how many hours did you watch TV last week? Here are their responses. Oh, send data to the calculator. Oh, okay, I'm not really familiar with that. Whatever, I'm going to use my own calculator because it's way cooler. The TI-84 that you're hopefully using. So I'm just going to go, one way to do it, the very direct way, would be to say 9 plus, we're looking for average. We're going to add them up, divide by how many we add together. Okay, add them up, divide by, we go to 7. So the average student watched 14.4, about 14 and a half hours of TV last week. Now, to help you with the count, you could also do green, window, I'm sorry, green, y equals, and then option 1 that pops up is numerator over denominator. You have to make a fraction. Then you could say 9 plus 13 plus 19 plus 15 over 7, using the arrows to navigate around. And then, hey, there's that 101 again. And then you could type 101 divided by 7, or you could go to math, take decimal, say, turn that into a decimal, get it that way. So anyway, that's a little bit about how to do this. All right, Bob wants to find the average time it takes for Lincoln High School students to run one lap around the track. So he will consider a sample of students to find the average time. Well, that makes sense. You're not going to use just one student. What if that student is, really fast or really slow, or just having an off day or whatever? So which units could be used for the unit of measurement? Well, we're talking about average time. So, hours, seconds, minutes, those would all work. However, hours is probably not going to be the most helpful, but it could work. And again, hours, you could measure it in hours, but that would be probably less easy, less efficient than seconds or minutes, but it's a unit of time. Okay, part B. Which of the procedures below would be the best way to find the average time? Whoops, I need to click on that. Okay, so you could randomly pick 6 students, you could randomly pick students, that's the first 2, or you could use volunteers. Well, random usually works better if you're trying to get, a number that represents everybody. Who's going to volunteer? Well, probably people who are good at this, people who are interested in actually doing it. And therefore, you'll probably get faster times than than the true average. So you typically wanted to go random. All right, so we're not going to pick the last two because that involves volunteer. All right, so, okay, you could pick 6 students or 24 students. Well, what would be better? Well, if you only have 6 students, and one student does really good or really bad, well, I should say really fast or really slow, then that could throw off the average really easily because there's only six numbers you'd be adding together before dividing. But if you have one student that is really unusual, really high, really low at the time, out of 24, that doesn't affect things nearly as much. Okay. And so I'm starting to think this second option right here. Then there's one more thing to think about. At the end of the first and second, it says, have them state their own times. Okay. Have them state their own times. Well, what if they exaggerate or lie or just don't measure correctly or whatever? Wouldn't it be better for you to measure all of the times? And then even if you're off, well, you're going to be off on all of them by the same amount. And at least there's that consistency. But because it's your experiment, you're going to probably make sure that you're not off. Okay, you're going to make sure you're really accurate. And so having people volunteer their own information, self-reporting as they call it, that does not tend to be as efficient as you measuring everything, at least when possible. So there's several things there to think about on this part B. All right. All right. Now, same thing, except now it's problem type 2 instead of problem type 1. East High wants to estimate the number of seniors who plan to go to college, a 4-year college. Answer the following. Which of the following surveys probably would best represent the entire population of seniors? Population means the entire group you're interested in. Sample means just a portion of that group. Okay, but population means everything or everybody you're interested in. So what would be the best way to represent the whole group? Okay, 25 seniors are randomly selected. I like the random, that sounds good. 15 plan to go to a 4-year college. And so then you might say, oh, it's like every 15 out of 25. Okay. Or part B, I'm sorry, the second option. 25 Glee Club members are random selected and 18 plan to go to a 4-year college. Well, you might say, hey, that's not bad. And you're still picking 25 and 15 and 18 is not, that different. However, we could say, well, 15 out of 25. Okay, so the first sample says 60% are going to a 4-year college. Second sample says 72%. Well, I think there's an argument to say that's pretty significantly different. All right, so what about the last one? 25 honor roll students are randomly selected from the class and 16 plan to go to a 4-year college. Okay, first of all, I would expect that number to be higher, but whatever. That is quite close to the 15. That's going to be 64%. But we're trying to represent the entire population of seniors. Okay, well, if we want to know about Glee Club members, we'll test the Glee Club. If we want to know about honor roll students, we'll test the honor roll or get our sample from there. But we want to know what's going on with just seniors generally. So the first one is going to be our best choice. Okay. Now, there are 350 seniors at East High. Using your answer from part A, estimate the number of seniors who plan to go to a 4-year college. All right. So 350 seniors. Let's go back to the calculator. Well, we found that from that sample, 15, here, I'll just go like this. Okay, there were 15 who said they were, out of 25 who said they were going to a 4-year college. That's 60%. So 60% of these 350 seniors is going to be 210. 200. So we expect, I mean, it might not work out that way, but we expect 210 seniors based on our sample of 25 seniors from the entire population of 350 210 of those 350 are going to go to the, going to go to a four-year college. Okay.